This is a view down a microscope of a thin section of kidney. The kidney has been processed, sectioned and stained to allow us to study its cellular structure. If you try to cut a piece of fresh tissue and look at it with the microscope, all that can be seen is a structureless blob. There are several obvious problems. It is not permanent, so the tissue decays. It is difficult to cut sections thin enough to allow light to pass through the section. And it lacks colour. These difficulties are overcome by fixation, provision of a support medium for the tissue, and staining. To preserve fresh tissue, it is placed in fixative for a length of time suitable for the size of the piece and the type of fixative used. For example, a specimen of this size would be fixed in formalin for approximately 36 hours. The fixed tissue is transferred into a labelled plastic cassette that is then placed in a stainless steel carrier. It is hooked onto the arm of the automatic tissue processor. The carrier is lowered into the first bath of 70% alcohol. The timer set. The processor holds beakers of alcohol of increasing concentration, and as the machine goes through its cycle, the tissue is dehydrated gradually to avoid excessive shrinkage. Paraffin wax is not soluble in alcohol, so after dehydration the tissue is exposed to a solvent that is miscible with both alcohol and paraffin wax. These solvents are known as clearing agents because they also make the tissue translucent. The last few beakers in the machine contain the clearing agent. This laboratory uses a non-toxic organic solvent, histoline. At the end of the cycle, the specimen is immersed for an hour or more in pots of molten paraffin wax. The end product is tissue impregnated with molten wax. The next step is blocking the specimen in solid wax. The carrier is transferred to the tissue tech embedding station, and the cassettes immersed in the wax reservoir so the warmth keeps the wax molten. The tissue is removed and orientated as required in a metal mold which has been filled with molten wax. The base of the cassette with the specimen ID on its side forms a lid for the mold. The mold is topped up with extra wax and placed onto the adjacent cold plate. The wax solidifies and the paraffin block with the specimen is removed from the metal mold. The tissue sample is now ready for the next step, section cutting. Sections are cut using a rotary microtome. The tissue block is clamped into the microtome. The knife is inserted and clamped into the knife holder. The knife stage is eased towards the block. When final adjustments have been made, the stage is locked in place and the dials set at the required thickness, routinely 7 microns. By rotating the handle, the block is advanced by 7 microns and lowered down past the knife to produce a section. These sections of wax and tissue form a ribbon that can be lifted off the knife and laid down in strips. Due to compression, the tissue sections are slightly wrinkled, but most folds can be removed by floating out the ribbon or individual sections on a warm water bath. Sections are collected up onto a microscope slide and dried in a 40-degree oven overnight. The wax within the tissue sections is dissolved away by the clearing agent. The slides are then rehydrated since the solvents are not miscible with the dyes. This stage is simply a series of alcohol washes of decreasing strengths down to distilled water. The dewaxing and rehydrating steps are referred to as bringing the sections to water. The sections are now ready to be stained. Hematoxylin and eosin are routinely used to stain histological sections. Hematoxylin stains many nuclei a blue to black color. Eosin stains cytoplasm and intercellular components pink. Sections are overstained in Harris hematoxylin solution, and then they are placed in a weak ammonium solution to produce a deep blue color. Overstaining with hematoxylin results in many tissue components being colored blue. The dye is then selectively removed until the nuclei can be seen clearly. This is checked with the microscope. This process is known as differentiation. The slides are then stained with eosin. To make the section permanent, it is dehydrated in absolute alcohol and then cleared in the clearing agent that is miscible with PIX. The clearing agent makes the section translucent. PIX is a synthetic melting medium and acts as a clear glue-like substance that adheres the cover slip to the stained section. A drop of PIX is placed on the cover slip and the slide with the stained section is lowered onto it. The PIX will harden after the slide is placed in a 40-degree oven overnight. The mountant PIX has the same refractive index as glass. This means that in the light microscope, light rays are not further distorted as they pass through the section, then the mountant and up through the cover slip. In summary, tissue processing involves fixation, where the tissue is preserved, processing, where water is removed and the tissue is impregnated with wax, section cutting, where a thin section is cut from the paraffin-embedded tissue, and finally staining, with hematoxylin and eosin to give the H&E stained section.